Hi, everybody. I've already been introduced by the wonderful Evan. So today I'm going to talk about a set of work that we've been doing. People have seen versions of this. This is another short version with a slightly different take on it. It's been going on for the past few years, but this really goes back about 20 years of things that have been going on in supply chain, in particular for emerging technology. So just to put the lead up front, if my fingers will actually work, um, about 2 years ago, we were asked to work on looking in particular at the battery supply chain, focusing on one particular company, but to expand that to look at the entire supply chain for batteries that was coming into play. Why? Because we're using it everywhere. People were buying batteries from all over the place for everything, not just as part of the infrastructure bill or any of those things going on. It was really being seen as a type of energy that could help us deal with some of the consequences of various power things that were going on in the system. So they were really popular. Everyone was looking at buying them. The market was growing massively. But if we step forward, when we started to do this analysis to put the sort of lead up front, we were finding that about 90 to 95% of the digital components for control of these systems, things like the inverters, the chipsets, everything else, were from a PRC made, owned, or derived hardware or software control component. Spin the lead up front, when I was first asked to say how much of this is from China, the answer was most of it. Can we do a different analysis to say, how do we deal with the fact that most of this is from China, both from a policy and technical standpoint, and deal with it quickly? So moving on, just in context, it's not just for the electric system. People are putting batteries and inverters on backup generators for tier one facilities, for example. Hospitals are looking at it. Prisons, interestingly, Alcatraz just put a big battery, not that they're open yet, but Alcatraz just put a giant battery on their system. Comm sites, if you go out there, you'll usually see big boxes that, by the way, aren't diesel generators. Those are batteries now. So it's a growing thing that's basically on all sectors at this point. They're looking at buying these systems. So it was a fairly urgent concern of, hey, if all of this is from China, did we just actually insert through the front door an issue with all of our infrastructure at the same time? So talking of canon events, to use a Gen Z term just now, I worked in interconnection back in sort of 2004, 2006, around when ARA was coming into play, which was one of the earlier infrastructure bills and recovery acts that was going on. When we were working and installing a lot of the solar, what we started to see, we'd set this target of $1 a watt for solar at the time. And what we started to see was that there was just a flood of Chinese panels started coming into the market at that point. We couldn't actually make them in this country cheap enough to meet the $1 a watt target that was being set by the US at that time. So things went offshore. And that was kind of how we got to here. This isn't one admin that did anything in the last 2 years, 4 years, 6 years. It's really about 20 years of decisions that led to us having the majority of our power electronics supply chain manufactured offshore at this point. So sort of stepping forward on things that have happened since then, there's been this boom of storage and new technologies. One of the biggest companies that started to dominate the market was CATL, who I'll call Cattle now. I'm not referring to cows, I'm referring to Cattle, the battery company. And that was really what was going on, was around middle of 2023. The picture you can't see very clearly, but this was a picture taken on a military base where they were very nicely cutting the ribbon to say, our storage site is open, we're doing really well. It's almost like a selfie. And I remember seeing this on the news because I follow that news. And I was like, it says Cattle right behind their head. Did they actually know that this was like the biggest Chinese battery company in the world? Or before they took that selfie, could they have just put a sticker on it and not had that in the background? That would have been helpful. But it was very clear that people started to look at it and be like, where'd you get that from? And so that became a challenge. Fast forward about middle of 2024, there was a push to actually remove that from that site. A number of people announced that they were going to change their supply chain. They were going to get a US supply for these systems. But if you fast forward to now, those RFIs that went out from utilities saying, we want US suppliers for everything, came back with, we can't get US suppliers for any of this, and we have to actually install it for reliability. So how are we going to do that? And that's how we got here. And that's really how this study came about, was when the cattle issue was starting to spin up. That was really the response we had. Was I get asked often, say, can you tell us everywhere this system is? And my answer was probably everywhere. They are the biggest one in the world. So let's come up with a new approach. And so looking at the outcomes of the work we did, we didn't want to just go for like, hey, here's all the ways you're going to rip and replace this. We wanted to actually do a slightly different set of work where we would state what the supply chain solutions actually would look like near term. So 2 to 4 years, how would we boost domestic production of the key components that you actually needed? Not just the battery cells, there was a lot of work into critical materials and to boost that manufacture. How do we actually boost production of advanced power electronics? As in the controllers, the things that will be attached to that make it connect to the grid, the control components, not just the cells that were sitting there. I jokingly call them the dumb goo, but the electrolyte that was coming wasn't really a controllable thing. The actual inverters, the power electronics are controllable. So those were the things we were worrying about. And yes, I said inverter 3 times. So, here we are. Policy and regulatory solutions was another piece of this. As a national lab, we don't tend to go into policy too much, but in this particular case, there was a number of policy reasons that we were having challenges with things like, can we actually inspect all these equipment when they come into the country? Can we look at what's inside it? It turned out not really, because there was a lot of contract things and laws that were stopping us from just inspecting someone's equipment and taking their firmware out and looking at it. So we're looking at policy controls for that, and then also design solutions. We already had a decent install base of this equipment on the system already. So the design solutions we were looking at was, what do we do with the stuff that's there already? If we find issues with it, how do we fix that? What are the key things that we might actually need to remove? How do we do that? What do we do with the things that are in design now? Because if you look at the queue for things being actually installed, it's enormous. And then how do we help people do things better in future? Like, how do we help them make better choices, better design choices? How do we get to this longer term future for things that are planned as well? So is that working? So for anyone that works on batteries, this is an architecture, not the architecture. There's multiple architectures. That question has came up before. One of the things we did was go through and prioritize all of the components. Often security researchers will buy one piece of equipment and say, I've looked at this inverter and it has something weird in it. Now we decided it's all terrible. Those are not that that's happened recently, but it's actually a series of components that are connected together that all tend to have a function within the system. It's a system, not just one thing. So with the battery cells themselves, you can't really do that much with them on their own without their BMS, without their inverter, without their power conversion system. And so we went through and used a technical approach to prioritize what actually mattered in the big battery systems as they got connected to the grid and the substations. And then what would we do with those particular pieces? Once we picked the most consequential components, we also took a dive into those components to say, what are the active components in this that we could maybe prioritize for manufacture, and then worked backwards from there. And there is a whole long report that goes into this. So everyone knows it's about 90 pages. I joke with people, my PhD was in batteries and power systems. So sorry is all I've got to say. But there is a report that goes into this for more detail. Again, we prioritized the components and then said, we're going to look in particular at the supply chain of these and work out solutions for these bits so that we can then at the systems level have better approaches. The other part that came into play, people were saying, oh, it's all about solar, renewables, all those things. We kind of answered that with, where does everything cross over and manufacture for these companies? Because organizationally, we were also seeing some challenges, in particular when we looked at things like the supply chain overlap with electric vehicles for the battery cells. There were companies essentially that start off with, hey, I made a widget, I made a type of inverter, I made something. They either start white labeling someone else's, or they build their own and then move into the market. With investment, they end up growing super rapidly. Give them a couple of years and they'll probably be selling a turnkey battery unit, which is really, when you see the name on it, that's the turnkey battery unit they're selling. They'll be selling electric vehicle chargers. They'll have integrated distribution transformers. The way that these companies, in particular PRC companies, scale is something to watch. They go straight from one thing to all the things, and it's both a challenge and a threat to us that they are able to do that where we don't often scale that quickly. So what does an actual attack look like? You can say lots of things of, if this happened, everything would fall apart. That happens a lot. But if I were to say what an attack could look like, it's kind of interesting because one of the most common and useful features on the inverters and on battery storage is also probably one of the weaknesses. To give an example, the picture that's on the left on the screen, that was actually an event that happened in the west of the country where during an event, a number of the batteries and solar is an actual grid event, which was essentially a fault on the system. the batteries and solar all behaved the wrong way, as in they're meant to do a certain action when they receive a grid signal. For whatever reason, they did the opposite. And everyone's like, the first thing people are like, is it a cyber attack? I'm like, nah, it's probably a fault in the firmware and the control system, but okay. But it wasn't a cyber attack. It was the firmware just had a weird fault in it that during a certain condition, it did the wrong thing. It didn't cause a massive grid event. It caused a small blip on the system, but it was enough that there was a small investigation into it. One of the findings was, hey, we need to update all of our firmware on all of these devices because we found what this error is with the firmware. They contacted all of the manufacturers who could push the firmware to it to say, hey, you need to fix your firmware. And their response was, yes, we know what's happened. We've already pushed hot fixes to all of these devices, the end. And everyone's like, did you do it? And this was a few years ago. And the answer was kind of like, you just did it? And everyone's like, yeah. And they're like, we probably need a rule to stop you doing that again. And that was a interesting point that the problem was somewhat fixed before it was actually flagged as a problem. This has also now led to there being things like inverter-based resources are now becoming registered generators, meaning they can't just do that anymore. But it was there before it actually happened. So this is more what something could look like. We ran a small exercise. I called it Sunsplat, I think, at the time. That probably didn't go down as a name very well. But it was to show like an event like this. What if you pushed a firmware device to millions of inverters across the country and they all bricked? Like, who would you actually call? And the answer was the inverter company. We're like, you mean the one in China? And they're like, all right, okay. So there's definitely a thing to be fixed here on how we exercise things. We also went through, I won't say where it was handed to me from, but we were handed a chart that was made by another country that said, we want to rank all of our supply chain now. We want you to do this too. We want to put all of them in a scale of vulnerable, all the companies that sell to the US or other country on a scale of vulnerable, malicious, or dominant. It was just three things like linearly. And I was like, and when I looked at the way it was classified, I was like, you mean we're going to say everyone's malicious when they're not from your country? Because that's going to be a really big challenge for you ever buying equipment in the future. And so we remade this chart for this particular challenge to essentially say vulnerable and dominant are something we can look at, but we used a Dungeons and Dragons scale here, which was going from chaotic bad to lawful good. And how do we put it on a 3D scale of if they're following certain technical requirements and other requirements. So good safety record for batteries is a really big one because safety is probably higher than cyber for a concern. Good safety record, meeting security requirements. Even some of the known US suppliers won't meet certain utilities security requirements as well. Are they mature or are they brand new to the market and suddenly popped up? And then, well, are they a PRC integrator owned, operated? So how do we then scale that to show how do we get to the better side of this, or which companies should we really be looking at more closely and considering if they shouldn't be on the system or not as well? With the idea that when you move down to the bottom left, those are kind of the worst case scenario where all PRC, they're pre-immature, they won't meet security requirements, and they have an unknown safety record. That means they're more likely to go on fire, they're more likely to be controlled, they're not mature enough to have any kind of program anyway, and they are all connected to their Chinese owner originally as well. So those are kind of the worst case. On the top right was our considered best case, which doesn't exist, which is all US, mature, meets security requirements, and has a good safety record. So the top right was really the unicorn. And we used this to basically scale out how we would work with different integrators, like who we would consider. I'm obviously not putting names up here because that's how I get sued. But how we scale up integrators and work with them to say, these are ones we could really work with to make this better over the future and how they could help replace parts of the supply chain that we have problems with. But then look at sort of the bottom left, or these are the ones we should probably start considering getting off the system, not encouraging their installation. Here's how you work from that from a policy standpoint. Again, the idea being it's meant to be rapid. There's a lot of questionnaires you can send out to folks, but this was how do we rapidly say where we're starting to see emerging risk as well. On organizational risk, who are you going to call was a big problem. If you look at Texas, for example, one site or one company and set of sites we were looking at that made up about 800 megawatts, now close to a gigawatt of generation or battery storage in Texas. There was originally one developer who'd bought a site to connect. They got an interconnect approval from the utilities. That's where the electrons actually go, like where the actual physical electrons are connected to in the grid, which is different to who owns it and where the other connections go. They were buying the power through a power purchase agreement. So that developer owner was then bought by another one, which made it an aggregate now of about a gigawatt. So if this whole other one bought them, I will add both of these companies were finance companies, not technical companies. So at this point, when I looked at who was owning it, I was like, finance bros, awesome. And so then we got down to, they developed the site fully, it was connected, things like that. Then they got bought out by a whole other company as well. So at this point, there was another aggregate that had been added together. And this only happened over a couple of years. There was 3 different purchases because those main companies' goal were to be bought, essentially. When you looked at the technical connections of what could actually talk to these systems, they were all using Sungrow Castle units. So these systems could talk there because they hadn't connected these systems in a way that they were controlling the connections, which is one of the solutions to all of this, which finance companies are not very good at, as it turns out. They also had fourth-party O&M going in there, which is a whole other company that comes in to help them. And they were connected to the market via fiber connections as well. So it was basically a massive spider web of who you would actually even talk to or find the original owner as. And if you could find someone that wasn't a finance bro, that was really helpful. But you couldn't actually really find out who to talk to if there was an event. And at this point, they were at a gigawatt. They're more now. I think they have a better owner at the moment, but there's still 3 or 4 owners to talk to if there's a problem as well. And it's a really difficult challenge. So we have solutions. We do actually know how to secure these systems. A lot of the problems that we have are really around configuration, how it was configured when it was installed, who it talks to. From a technical standpoint, we actually do have solutions that have been worked on over the last 20 years as well. We just need to actually use them to reduce the risk. So that was one of the things we were doing, was putting together a portfolio of those solutions so that any asset owner could take 10 of the things that made most sense to them, do that, and then hopefully secure around the worst case scenario and move forward. We're using cyber-informed engineering to do that. I think Ginger will be talking about that later, so I won't go into it too much. It's great to have a partner talk. But we did look through the other solutions, the big one being rip and replace instead of securing around and through. Rip and replace was being recommended to a lot of places. Similar to Huawei, they were saying, let's get rid of these 7 to 10 suppliers that are on the network, get rid of them. I did the math, unfortunately, and it was around, we'd have to fund $12 billion at minimum to those companies to rip and replace. Bear in mind, Huawei was a fund that was used to help replace it. It was meant to be about $4 billion. Huawei was only funded to $1 billion in the first year, and we're about 5 years later, and we haven't got rid of a lot of it because we didn't get the other $3 billion or the equipment to replace it. Also, it would take about 4 years to replace one state's batteries alone, given the supply chain. And there's about 70 options currently for Chinese-made batteries. So if you get rid of 10, there's 10 others coming behind them that will just grow as well into the market. Again, not saying we shouldn't get rid of some of them, but those other 10 that are coming behind them might not have good safety metrics. For example, there's one company in particular that suddenly appeared on the market when this was all happening, and they have a good record of setting fire to things. So that's cool. But they just come in the back and they will start saying they're going to supply it. If we don't just ban them one by one, we're just playing whack-a-mole at that point. So how do we get there? And Huawei are still around. Interesting that's related to this. Huawei are also globally one of the biggest inverter companies as well. They left the US market in 2019. Cool. Then in 2022, they went from number 2 to number 1 globally for supplying inverters. So they're still there. So dealing with the secure design is really the solution we're looking at, and then working through an actual secure around and through. So secure operations for these systems. What do we do? Domesticate. I give up. I'm not going to say that word. So secure by design, policy and regulatory solutions. And so we put together this sort of portfolio to help with that. Again, you don't need to read it all. It's in a report, but with the idea being, how do we scale those solutions to the right people? Who do we work with? Who can we work with? Because just so you're aware, if I turn up and say, hey, Cattle, can I help secure your system? That doesn't go as well for my job. But there are others I can go work with, like the US integrator market, to help them secure, even if they've bought the Cattle cells, for example. And then there are the ones that we're starting to build in this country. How do we help them build better things with things like secure comms, secure equipment manufacture? Because fun fact is, even if they build it here, it doesn't mean they didn't build it to the same design standard. That means they're communicating with everything anyway. So how do we fix that? Just quickly moving on, Ginger will actually probably mention this. We did an actual cyber-informed engineering for BESS tool and report. It's actually worked really well. We're working with 10 different folks just now who are implementing it. Two of the largest US integrators have built it into their business cases now, which is great. They're using it to build their actual cyber business case. We partner that with going out, and Sherry's here who helped write this as well. Sherry, so we also wrote a procurement guide because one of the biggest challenges we saw was people had things written into their contracts, which essentially prevented them from inspecting or doing anything with the equipment, which might protect the IP of the Chinese company. It doesn't help us secure or inspect it. So we were trying to sort of nationally help people push out this from their contracts. How do you remove the things? One of the big recommendations, you should probably read your contract, was also pretty good. But reading your contract so you know what you've signed up for, because some people also started to find out that they'd signed up for, you will always have maintain a connection to, oh, Ben's here. He can talk about CIE BAT. Hey, Ben. But how do you maintain those contracts? And how do you find out that you've managed to put into your contract that you will maintain a connection with the owner forever because of your warranty requirements? Some people didn't notice they had that or why they had a modem in their system. It was because they agreed to it in their contract. So how do we get people to do that? Well, we wrote this guide partially for some of the federal awardees as well. When they were buying equipment, this was really written for them to say, hey, you bought your first battery. Here's what you need to look at. So this one very quickly, we did also, I can say all these words, but getting ground truth is, I hit the wrong one. Getting ground truth is really important. We have a hunt kit, whether we use Malcolm, a commercial tool, anything else. You put together a hunt kit with our teams so we could actually go out and inspect things on site and see what was on the ground. Buying the equipment, if Idaho Lab comes in and says to this company, I'm going to buy your equipment, do you think they're going to send us the bad version? So we actually wanted to go out in the field and say, hey, we want to go see what's in your system just now. Look for anything anomalous. Look for your configurations that were potentially just to the wrong place so you can reconfigure it. But just actually get ground truth on problems that people were highlighting potentially to news stories rather than actually like going out into the field and seeing these things. And we've done this now, multiple locations. We picked a set of high priority places first. And now it's part of a technical assistance program where entities can just come ask us to come inspect their systems and tell us what's wrong. We're doing that a lot of places. People are also sending us retired equipment, which is kind of interesting. As in, we're becoming I'll call it the trash can. But as in when people are retiring equipment, they can send it to us and we can see what was there as well. So we can potentially fix it in future also. So yeah, we've been doing this through technical assistance. People can ask us for it and we will turn up, usually smiling. So just in summary, we've got a number of solutions here. There's a longer report. I think I'm on time by 5 minutes. So I can take a couple of questions. But we're really looking at how to adopt this. Again, it doesn't matter what I say to you right now. If no one actually does the solution, we will still have the problem for this supply chain. So that's really what our goal is, to get people to take these things, forcing inspection, rationalizing the regulation, configuring it correctly, and also sort of safely integrating it, because some of the safety choices you make actually mitigate a lot of these biggest consequences as well. So the end. Questions?
Can I ask the first question?
Yes.
Just because I guess I'm a lawyer, so I feel like we could regulate and maybe procure our way through any problem. Is there the right sort of standards? Has someone looked at sort of how we can like create a set of NIST standards and maybe do what we've done for the rest of the DoD infrastructure with like TMMC, where we said, okay, we're going to give you a really long runway. You're going to have to adopt things slowly, and maybe if you don't want to adopt them, then you have to put, there's going to be really difficult management controls on top of it. But that way we can sort of get to the problem with all the debt we have, with all the bad infrastructure in there over time.
The first step of that was the addition of inverter-based resources to the NERC efforts as well. That was their sort of first step into trying to actually get that part regulated. Problem with those kinds of standards, especially for inverters, is inverter-based resources and interconnects have been really good at splitting their interconnects for the last. I might have been an engineer that did things like that. There's ways around it. It doesn't mean they're not going to end up with this equipment. They might just do the minimum, where we're saying in this case, they probably need to do a bit more than minimum to secure around the worst equipment as well. So it really depends on what we find. And lawyers get involved from both sides.
Other questions? Sorry.
Yeah.
Yeah, that's a challenge. But the thing is that the other problem you have is that you've got to regulate from both directions, right? The physical and reliability, in this case with the grid, but in other scenarios and abilities, as well as the cyber. And we have this really complex problem where you need to write standards that are flexible enough to be able to be reactive in real time, but not so flexible that they don't hold up in the enforcement of legal construct. Nobody's figured that out yet either. But I think the NERC model, I know a lot of people hate it. I'm a huge fan of it because I think it's a very strong model. It involves industry input. It's built by the SMEs. The problem we had at the front end is there weren't enough lawyers involved in the writing and drafting, and that's where they hit it. And it can be matured. The biggest problem with regulations is it's just slow.
The record reflects someone commented that there weren't enough lawyers involved in something.
Yeah, I was one of the very few. There's another
I do think
I
do think the Buy America Act, when you look at some of the things that are successful.
I can make a comment on that one. Well, the interesting thing for this equipment for things like Buy America was they can, the few things that have managed to stamp and say we meet that standard, they've been using that. They still bring all the equipment in from somewhere else or the PCs, but they got a US person to help build it in this country. So that is how, using the hours of manufacture, they were able to meet it. And it didn't mean they built it from a US piece of equipment, unfortunately. So there's other things coming in that help with that, though, like the 50% rule and things that might get us there better. So
sometimes just read the report, and let's give a big thanks to Dr. Emma Stewart.
Thank you.